welcome. Welcome, and I'm very pleased and glad to open this conference. This conference was planned to celebrate the journal, the economic journal of this university, Research in Economics, which is one of the most important Italian journal in economics, most important in Europe. Certainly the oldest of the journals published by this university. We publish several journals, in particular in the humanities, but this one in economics is certainly the oldest one. More than 70 years ago, it was established in Italian, and then it became published in English about 20 years ago. It's the oldest, and this follows the tradition of Ca' Foscari being the oldest business school in the Western world, probably jointly with Antwerp in Belgium, which was established more than 150 years ago. And it's 40 years before Harvard or other well-known business schools. But many things happened for the first time in Venice. And of course, this is no surprise that even a business school was established in this city before many other things in many other places. I'm quite happy, therefore, to welcome all of you, in particular the outstanding speakers of this conference. We have two Nobel Prize winners. We have excellent speakers, top economists, leaders of our profession. And I'm really happy to see all of you here, and really thank you, all of you, for your contributions during the 2 days of the conference. Quite happy to see students here and colleagues and all those who will benefit from the contributions that I hope will be then published in the journal, because I believe that the contents of this conference are very important and will help further developing and enhancing our knowledge of economics. The facilities that we provide are this building, Ca' Foscari is the name of the building, is the name of one of the oldest buildings in Venice. It takes the name from the family, one of the famous family in Venice that owned the palace for many centuries, and now it's the main headquarters of the university. We will try to fix the weather. By lunchtime, the sun will be back. But I really wish you 2 wonderful days, 2 very interesting days. And I thank Professor Casavillan, the editor of the journal, and director, the chair of the Department of Economics, for having organized this conference. And I thank all of you for your participation. Guido, the floor is yours.
Thank you very much. As usual, our president already said almost everything, so I'm going to be very quick. I'm very pleased also to see many of our PhD students here, and particular welcome to them. And I also to thank very much our president, because more than a year ago, basically talking together, he had the idea of organizing an international workshop in economic theory. Okay? Usually we have a lot of workshops in econometrics, applied economics, all that stuff. Well, economic theory lacked for maybe too much time. And he gave me this idea and the freedom of doing everything. We talk about our journal, and I have to add the fact that this workshop is completely financed by the journal. Okay, the editor of which nowadays is Elsevier. I want also to ask some people who helped me very much, especially during a tough period of time, because the secretary of the journal is here. And therefore, I'm going to follow the alphabetical order. I'm particularly grateful to Mrs. Valentina Collu, Mrs. Vania Levorato, and Mrs. Paola Vescovi. They helped me basically to solve all the small problems that usually have while organizing this sort of workshop. Of course, a big thanks to the 10 speakers who, I have to tell you the truth, accepted almost immediately my invitation. Building up a group of people which is really, truly outstanding in our field. I would like to mention them one by one, but I believe that everybody has the program. Therefore, I will skip that. You perfectly know who the speakers are. And I have also to give you a couple of information, a piece of information. First of all the presentations will be done by using slides, okay? And the slides will be available under request, simply by emailing to our, well, let me pass a word in Italian, otherwise it would be a combination between Italian and English, which doesn't sound very well, which is simply eventi at, I did it, at unive.it. Okay, so the slides are available. And after the preliminary version of the papers that I already received, I can tell you that in the final version they will be published on Research in Economics. But if somebody wants to have the preliminary version, he or she just need to email me, okay? After saying that, and not to lose time, I'm extremely glad and honored to introduce the 2007 Nobel Prize, Professor Eric Maskin from Harvard University.
Well, good morning, everyone. It's a great pleasure to be here in Venice at the University Ca' Foscari. I'd first like to thank everyone who made that possible, the president, Guido, all the other organizers. And what I thought I would talk about this morning is some recent work I've been doing with Partha Dasgupta on voting. This particular paper is actually part of a sequence of papers that we've been producing over the years. This one will emphasize strategic voting in particular. And let me take a few minutes first to set the scene. I will be talking about voting rules, which are a particular kind of social choice function. A social choice function is a way of selecting a social alternative, a candidate, if we're talking about a political situation, on the basis of people's preferences utility functions, rankings for the various candidates. And in the realm of voting, there are lots of voting rules that have been used in practice and have been considered in theory. Let me just mention a few of the best known ones. First of all, there's what's called plurality rule. In Britain, it's called the first past the post system, and this is the method that's used to elect members of parliament in Britain. It's used to elect members of Congress in the US. It's used in many other countries for elections. And it works like this. For each voter, we just look at the voter's top-ranked alternative. In fact, usually all voters get to do is to say who their top-ranked alternative is, and whichever alternative, whichever candidate gets the most votes, even if that's short of a majority, that candidate is the winner. So that's plurality rule. The next method is majority rule, or Condorcet's method. Now, you should think of voters as submitting a ranking of candidates. So they vote by ranking all the candidates, and the winner is the candidate who, according to these rankings, is preferred by a majority of voters to each other candidates. So that's Condorcet. Next comes runoff voting. This is the method used to elect presidents in France. It's also used in Russia. It's also used in Brazil. It's used in many other places also. The way that works is there are normally two rounds. In the first round, voters vote for their top-ranked alternative. If there's a candidate who gets a majority in the first round, that's the end of the story. That candidate is elected. But usually what happens, although this didn't happen in Iran a few weeks ago, there only had to be one round. But if no one gets a majority in the first round, then the top two vote getters go on to a runoff, and whoever wins the runoff is elected. Then there's what's called rank order voting, or the Borda count. I should say that majority rule, Condorcet's method, was developed by the Marquis de Condorcet in the late 18th century. Jean-Charles Borda, who developed rank order voting, was Condorcet's contemporary. They were both members of the French Academy of Sciences, and they both advocated their own particular method for electing members to the Academy. So Borda advocated the Borda count, which probably most of you are familiar with because it's often used in committees to elect a chair. The way it works is that voters rank the candidates. A candidate gets 1 point every time he or she is ranked first, 2 points whenever he or she is ranked second, and so on. And then we just add up a candidate's total points, and whoever gets the fewest points is elected. Remember, a low score corresponds to a high ranking. So that's the fourth method that I'm discussing this morning. Let me just mention one other method, which you can think of as utilitarian voting, if you like. We don't normally think of this as a voting rule, and there are some good reasons why in practice it's not used very much. in voting, but we could consider it. And under utilitarian voting, each voter submits a utility function. A utility function just assigns a utility number to each candidate, and then we look for the candidate that maximizes the sum of utilities. There's a variant of this principle which has been advocated by Michel Belinsky, in which rather than looking at the sum of utilities, we look for the median, the candidate who has the highest median utility. Anyway, I've now gone over some well-known examples. I could go over many others because the voting literature is full of different voting proposals. But out of this great multitude of voting rules arises the question, which should we actually use? None of these are the same. Why should we use one rather than the other? Well, the way that a voting theorist tries to answer this question is to first say, what is it that you want out of a voting rule? A voting theorist will try to break down the problem into fundamentals to say what criteria, what principles, what axioms we want a voting rule to satisfy, and then to check which voting rule or voting rules come closest to satisfying those axioms. So that's what I'm going to do here. In fact, I'm going to talk about axioms which have long been discussed in the voting literature. In particular, I want to discuss a criterion which is called non-manipulability. When we say that a voting rule is non-manipulable, what we mean is that it should not be in a voter's interest to submit a vote other than her true preferences. In other words, a voter should not have the incentive to vote strategically. Now, why do we want voting rules to be non-manipulable? Well, there are actually quite a few reasons. Let me mention two. The first is just the idea that if voters are manipulating, if they are misrepresenting their preferences, then in effect the inputs to the voting rule are being distorted. But if the inputs are being distorted, then the outputs will be distorted, and we may think that we're implementing a particular voting rule, but because of the distortion, we're actually implementing something else. So non-manipulability helps ensure that that the outcome, the elected candidate reflects the principles that we want the voting rule we selected to satisfy. But an idea which I think is just as important, if not more important, is the idea that manipulable voting rules make life hard for voters. If you're a voter in a presidential election or an election for a legislature, you have some hard work to do. That is, if you're going to be a good citizen. You have to read up on the candidates, you have to know where they stand on the issues, you may have to watch them in debates. There's a fair amount of time and effort involved. If on top of that time and effort, you also have to guess how other voters are going to vote so that you can strategically react to how they're going to vote, then your decision problem becomes at least an order of magnitude more complicated. It's hard enough figuring out your own preferences. Trying to figure out other people's preferences can be exceedingly complicated, and a non-manipulable voting rule cuts through that problem, simplifies that problem by ensuring that a voter doesn't have to worry about how other voters are going to vote. A voter just has to reflect how she wants to vote. So that's non-manipulability. And I think it's an attractive condition, but unfortunately there's a famous negative result about non-manipulability. It's called the Gibbard-Satterthwaite theorem. And what this theorem says is that if there are 3 or more candidates running in an election, then essentially no voting rule, or at least no reasonable voting rule, is always non-manipulable. There are dictatorial voting rules where one voter has all the power, but those are not very reasonable. I'd like to make the point, though, that there's a sense in which the Gibbard-Satterthwaite theorem is too pessimistic. It's too pessimistic in the sense that when it says that a voting rule should be non-manipulable, it insists that the voting rule be non-manipulable in any conceivable circumstance. That is, whatever the voters' preferences turn out to be. And in practice, there may be circumstances where manipulability could occur, but those circumstances are just not very likely. So we won't worry about, we needn't worry about them very much. And in any case, after getting a negative results like Gibbard-Satterthwaite, it seemed to us that the natural follow-up question is, well, we may not be able to get non-manipulability all the time, but which voting rule or voting rules are non-manipulable as much as possible? That is, more often than others. And it's this last question that our paper is concerned about. So I'll first try to formulate the question precisely so that it can be given a clear-cut answer, and then I will show you what the answer is. Actually, there are 2 answers, depending on which combination of axioms or principles we impose. So that's my introduction, and what I'm going to do now is to show you our model. I'm taking it for granted that this is a primarily economics audience, so that I'm hoping that some of the terms that I will be using are already familiar, but I will be trying to explain all the terms as I go along anyway. So here is the model. The model first consists of a set X that you can think of as the set of all candidates who could conceivably run or stand for office in an election. So these are not necessarily candidates who end up actually running, but they're in the set of conceivable candidates. The one non-standard assumption in this model I'll be showing you is this one I have up now. I'm going to assume that the set of voters, the society that we're looking at is very large. In fact, I'm going to model it as a continuum, the entire interval between 0 and 1. And the reason for assuming that a continuum will become clear, I hope, in a few minutes. But when talking about a particular voter I, what we're interested in that voter is the voter's utility function. So a voter, for our purposes, can be adequately summarized by per utility function, which just assigns a number, a utility ranking, to each candidate. And that means, and I should say that I'm going to make life simple, and I'm going to suppose that these utility functions are strict, which just means that a voter is never exactly indifferent between two candidates. Given candidate A and candidate B, either the voter strictly prefers A to B or strictly prefers B to A. Why am I not being able to advance? Oh, I'm sorry. I pressed the wrong button. It was my fault. Now, each voter has a utility function UI. We'll describe the society as a whole by what we call a profile of utility functions. So the notation here is U box, where the box is a dummy variable that replaces each voter's I. So U box is a specification of utility functions for every voter in society. And given a profile, a voting rule is a way of selecting a winning candidate. Actually, we need as inputs not just the profile, which describes voters' preferences, but also the set Y, which is a subset of X, of the candidates who are actually running. So think of subset Y as the ballots, the set of candidates who have decided to stand for election. Then F of U box and Y is the winning candidate from the ballot, just an element of Y. So that's what a voting rule is. Now, actually, as I've described it, this isn't exactly right, because I've ignored the possibility that when the election is held, there might be an exact tie. For all of the voting rules that I described in the introduction, there is the possibility that that two candidates could emerge at the end. For example, with plurality rule, where we look at the candidate who gets the most top-ranked votes, it could be that exactly half the population votes for A, and the other population, half of the population votes for B, in which case there'll be a tie between A and B. This is where the assumption that there's a continuum of voters comes in, because if there's a large number of voters, the chance of an exact tie is exceedingly small. In reality, in an election with thousands or millions of voters, we never get exact ties because the chance of that happening is negligible. So I'm assuming a continuum of voters to ensure that the probability of a tie is zero, or put another way, that ties are non-generic. And that means that the correct definition of a voting rule is one where for a generic profile, or for a profile of preferences drawn at random, we get a unique winner. So that's what a voting rule is, and using this model of utility functions and voting rules, we can now formally define the voting rules that I talked about in the introduction. I'm not going to spend a lot of time on that, but if you're interested, this is the way of formalizing plurality rule. Remember, plurality rule elects the candidate who gets the most first place votes. if we're talking about a continuum of voters, we can't actually count up voters because there's an infinity of them. So we have to look at the proportion of voters who vote a particular way. So in this expression here, mu corresponds to a proportion of voters. This expression here corresponds to the proportion of voters who rank alternative A above all other alternatives B. And if A gets elected, that means that the proportion of voters who rank A first must be bigger than the proportion of voters who rank A prime first. That's the formal definition of plurality rule. This has to be true for all alternative candidates A prime. And similarly, I could define majority rule and the other voting rules I talked about formally, but I won't go through the details. If you're interested, you can look at the slides later on. Well, I said that what voting rule, the way that voting theorists talk about voting rules is to first specify what they want out of a voting rule in the form of principles or properties or axioms. What axioms do voting theorists usually concentrate on? I think it's fair to say that the voting rules that I'm talking about, with one possible exception, are highly non-controversial. They're all almost obvious as properties that you would want a voting rule to satisfy. And that's certainly true of this first property, which is called the Pareto property, after Vilfredo Pareto. The idea here is that if all voters prefer candidate X to candidate Y, and if candidate X is actually on the ballots, then it would be rather perverse to elect Y. It would be extremely perverse to elect Y if everybody thinks X is better. So Pareto property says this cannot happen, that we cannot elect Y. So I think that doesn't require further justification. The second principle is also, I think, quite self-evident, and that's what voting theorists call anonymity, but what you can also call the one person, one vote principle, and it's the idea that all voters should count equally. And the way that this is expressed formally is, suppose that you have voters send in their votes, but now we switch around the votes. So I gives her vote to J, and J gives her vote to K, and so on. In other words, the votes themselves are the same, but the voters who are sending in these votes are now different. So it's what we call a permutation of the votes. Well, if everybody counts the same, if all voters are equally important, the fact that we switched around the votes shouldn't matter the outcome. We should still get the same outcome as before. Put another way, voters' names should not matter. The voters' identities should not matter. Only the votes themselves matter. So that's what anonymity says, and it seems, I think, a pretty uncontroversial idea. It's a basic principle in most democratic voting systems. So that's the idea that all voters should be treated the same way. And the next property says the same thing about candidates. Just as we want to treat all voters the same way, the neutrality property says that we want to treat candidates the same way, which means that if we change the identities the names of the candidates. If candidate A becomes candidate B, and candidate B becomes candidate C, and so on, then we should change the name of the winner in the same way, so that if A was the winner before we switch the names, then B becomes the winner after we switch the names. Well, the three properties that I've talked about so far, Pareto, anonymity, and neutrality, are so basic, so non-controversial, that it's not surprising that all the voting rules that I talked about in the introduction, I actually talked about 5 voting rules in the introduction, satisfy these 3 principles. So far we haven't distinguished among them at all. The next axiom, though, which is the most controversial of the axioms that I'm talking about, does distinguish among them. But even though this axiom is controversial, it still has quite a strong rationale, and it also has an exceptionally good pedigree. It was proposed more or less at the same time by Kenneth Arrow and John Nash. In fact, they used the same name, although the Nash property and the Arrow property are somewhat different technically. I'm going to use the Nash formulation. The name of the principle is independence of irrelevant alternatives or independence of irrelevant candidates, and it says the following. If we have an election and the profile of voters is U box and the ballot is Y, and candidate X is the winner, then if for some reason some of the candidates who didn't win drop out, and we run the election again, X will win again. And so the idea is that if you remove irrelevant candidates who are not going to win anyway from the ballots, whoever won before should still win, because if anything, the case for this candidate is stronger now. He or she was already shown to be better in some sense than the other candidates. If we remove some of those other candidates, well, he or she is still better. So that's the idea. And one reason why this principle has been emphasized in recent years is that there have been some notable elections where the voting rules have violated this condition, and therefore we have got results which don't seem right. One famous example is the US presidential election of 2000. You may remember, well, some of you are too young to remember this election, but people like me certainly remember it. It's an election where the 2 main candidates were Al Gore, the Democrat, and George W. Bush, the Republican. Bush was elected, but the interesting point for my purposes is that there was a 3rd candidate in that election, Ralph Nader. The 2000 election came down to one state. In the US, there's in effect an election in every state. Everything came down to the state of Florida. If Bush won Florida, he would be president. If Gore won Florida, he would be president. In the end, Bush won Florida. But the notable thing is that Nader, this third candidate, got quite a lot of votes. He got almost 100,000 votes in Florida, and we know from a variety of evidence that most of the people who voted for Nader, most of the voters who voted for Nader, probably would have voted for Gore had Nader not been on the ballots. And if they had done that, then Gore would have won. So the voting rule used in Florida, which was plurality rule, violates independence in a big way, and violated it in a very dramatic way in 2000. We got a completely different outcome. We got a completely different history as a result of the peculiarities of plurality rule, in particular the fact that it violates independence. I'm not going to go through the details, but there was a similar story in the 2002 French presidential election. Now, France uses a runoff system. It's not the same as plurality rule, but it is also vulnerable, if you think about it, to violations of independence. And basically, because of this violation of independence, both plurality rule in the US and runoff voting in France were questioned. So it turns out that of the voting rules that I've described, only majority rule and utilitarianism satisfy independence. It's pretty easy to see that majority rule satisfies independence, because in majority rule, all of the comparisons between candidates are pairwise. So candidate A wins if a majority prefers A to B, and also a majority prefers A to C, and majority prefers A to any other candidate who might be running. If some of the other candidates drop out, well, the majority still prefers A to each of the remaining candidates. So majority rule satisfies independence. For a similar reason, utilitarianism satisfies independence. But the other voting rules that I talked about, plurality rule and rank order voting, runoff voting, do not satisfy independence. Well, that brings us to the final axiom, which I talked about in the introduction, and that's non-manipulability. Non-manipulability formally says the following. Suppose that people vote according to their true preferences, and the outcome is A. The winner is the outcome is X. The candidate X is elected. Now suppose that some group of voters, some coalition of voters, manipulate their preferences. So they vote strategically rather than according to their actual preferences. And when they vote in this way, candidate X prime is elected. Well, then it better be the case that somebody in this group of manipulating voters prefers X to X prime. Because if everybody in the manipulating group preferred X prime to X, well then the manipulation would presumably take place. Everybody in this group would send in the manipulated preferences, because they would all gain. So there should be some voter who doesn't want to manipulate, and if if that's true for all profiles and all ballots, then we say that the voting rule is non-manipulable. Now, non-manipulability implies that a voting rule can only use ordinal information. But, so I said that voters are sending in utility functions, which assign a number, a utility number to each candidate. But if a voting rule is non-manipulable, only the ordering of candidates, not the utility numbers, matter. There's a formal argument that I have up on the slide, but the reason is actually very simple. So suppose that there were two candidates, X and Y, who were running. Imagine these are the only two candidates, and suppose that you prefer X to Y, but you only slightly prefer X to Y. You like both candidates reasonably well. Well, if the voting rule took into account the utility numbers that you sent in, your intensity of preference, you would have an incentive to exaggerate how much you like X over Y, because after all, you prefer X to Y. You want to see X get elected, so you would have an incentive to pretend that you liked X a lot more than Y. So you would want to manipulate. That's true of any voting rule which takes into account intensity of preference, or it takes into account cardinal information. And that's why non-manipulability limits us to ordinal preferences. So it looks as though of all of the voting rules we started with, we're down to majority rule. Independence eliminated, plurality rule, board account, and runoff voting. The utilitarian principle, where we maximize the sum of utilities, is not ordinal, so it's eliminated by non-manipulability. So it looks as though majority rule is the only one left. Unfortunately, majority rule also violates non-manipulability, and the reason for this actually goes back to Condorcet himself. Majority rule, I'm denoting majority rule by FC, C for Condorcet. Majority rule isn't always defined, and Condorcet himself pointed this out. Suppose that the voting population breaks down into three more or less equal groups. One group prefers X to Y to Z, another group prefers Y to Z to X, the third group prefers Z to X to Y. Well, who will be the winner? Nobody. The reason is that a majority of people prefer X to Y. These people prefer X to Y. And these people prefer X to Y. So that eliminates Y. But a majority prefer Z to X. These people prefer Z to X. These people prefer Z to X, so that eliminates X, but a majority prefer Y to Z. These people prefer Y to Z, these people prefer Y to Z, so that eliminates Z. So none of the three candidates can be a winner, or put another way, there's a three-way tie. So that means that if we're going to use majority rule in an election, we have to have some way of breaking this tie. There are lots of ways of doing that. One way, this was proposed by the political scientist Duncan Black, is to use majority rule, Condorcet's method, if there is a majority winner, but if there's not a majority winner, to use the board account, rank order voting. The problem is that once we do this, we make majority rule we make it vulnerable to manipulation. And here's an example. So this is the example that I just showed you up here. So there's no majority winner here. So according to Black's method, we would use rank order voting, which results in X being the winner. But if we do that, then the voting rule becomes manipulable. These people, the middle group, have the incentive to send in the ranking ZYX, because if they do that, then Z becomes a majority winner. These people are putting Z above Y and X. These people are putting Z above Y and X, and so Z becomes the majority winner. And notice that these people all prefer Z to X, so they have an incentive to manipulate. And unfortunately, once we complete majority rule or extend majority rule, even if we don't use the board account, no matter what we use, Condorcet becomes manipulable. So we've now eliminated all 5 of the voting rules that we started with by one axiom or another. In fact, there's a theorem, this is essentially the Gibbard-Satterthwaite theorem, saying that there's no voting rule that satisfies all 5 axioms. But as I was suggesting, there's a sense in which this theorem is too pessimistic because, it insists that the axioms always be satisfied, and yet in practice there may be many cases where the axioms are satisfied because the violations are just very unlikely. Let's take majority rule, for example. Majority rule will satisfy all 5 axioms as long as we can rule out the kind of example that I showed you on the earlier slide. So this configuration of preferences is what's called a Condorcet cycle. Condorcet himself talked about Condorcet cycles. If we can rule out Condorcet cycles, then all five properties are satisfied. And there are some natural cases where we can rule them out. For example, it's pretty clear that in the 2000 US presidential election, we didn't have Condorcet cycles, and also in the French election of 2002, very unlikely that there were Condorcet cycles there either. So that suggests that we should talk about voting rules satisfying the axioms for limited classes of preferences. Since not all preferences are likely to occur in practice, we'll look at a limited class of preferences. We'll say that the voting rule works well on the limited class of preferences if it satisfies all 5 axioms on that domain of preferences. And now I have 2 results that I want to mention. The first says the following: take any voting rule at all, take a voting rule that happens to work well on some domain of preferences, it satisfies the 5 axioms on that domain of preferences, then it must be the case that majority rule also works well on that same domain. Furthermore, if the voting rule that we started with is different from majority rule, there must exist some other domain where majority rule works well, and the voting rule we started with does not. So there's a precise sense in which majority rule dominates every other voting rule. When the other voting rule works well, majority rule works well, and there will be cases where majority rule works well and the other voting rule doesn't. And that's true for every voting rule. The other results I want to mention, well, if there were time, I would show you the proof of this, but there isn't time. But the other results looks at what happens when we drop independence. So I said independence, which requires that when some non-winning candidates are thrown off the ballot or leave the ballot, we have the same winner. That's certainly the most controversial of all these axioms. There are good reasons for having it, but it's also interesting to see what happens when we drop it. So when we drop it, so now we only have 4 axioms. Once again, we get a negative result if we insist that the voting rules satisfy the 4 axioms all the time. But that suggests that, as before, we look at what happens when a voting rule satisfies the 4 axioms for a limited class, a restricted class of preferences. We'll say that a voting rule works nicely when it satisfies the 4 axioms on a limited class of preferences. And now we have the second and final result, which looks a lot like the first, except that now, in addition to majority rule, the Borda count is also one of the dominating voting rules. This result is the same as the first, except that we have joint domination by majority rule and the Borda count. So more precisely, take a voting rule which works nicely for a particular domain of preference, domain of preferences, then either majority rule or the Borda count, or perhaps both, must work nicely on that domain as well, satisfies the 4 axioms on that domain. And furthermore, if F star, so F star is either Condorcet or Borda. If F star is the one that works nicely on the domain, and F star differs from the voting rule that we started from, we can find another domain where F star works nicely and F doesn't. So exactly the same as the first result, but now the domination is joint by Condorcet, majority rule, and Borda. And there, let me just say one word about why this is so. I said that majority rule works well if we can eliminate these Condorcet cycles that I showed you in the example before. It turns out that the Borda counts, rank order voting, works nicely precisely when there are Condorcet cycles, so that the 2 voting rules together cover a lot of cases. They complement each other. And I think that's satisfying in a way. The majority rule and Borda are the 2 voting rules with the longest history. They go back to the 18th century. They've been intensively studied over more than 200 years. They both had their fierce proponents, Condorcet and Borda, who strongly disagreed with one another. What I find satisfying is that there's a sense in which Condorcet and Borda were both right. And with that observation, let me thank you for your attention.
Thank you very much, Eric. Are there any questions?
Is there a microphone for
Yeah.
the questioner?
Yeah, yeah. No, just wait for the microphone.
Well, I'm a PhD student from economics. Just a question on the applied side. When you talk about manipulation, the first thing that comes to my mind are the pre-election polls. I mean, we all know that they sometimes are not honest in their results. They use not honest methods to calculate them, to come up with the preferences in order to manipulate society and their voting. I would say, I would like to know what your take is on this issue and what should we do with them? Regulate them or just do away with them or let them do whatever they want? Thank you.
Well, you're certainly right that pre-election polls have a lot of influence on voters and make a big difference. And one important way that they influence voters is when voting rules are manipulable. That is, if I like candidate A best, but I see from the election polls that candidate A doesn't have much of a chance of winning, then under the voting rules that are normally used, I would be throwing my vote away if I voted for A. I will be better off voting strategically for some other candidate who does have a chance of winning, candidate B. So in other words, the reason why polls are so important is that they help voters manipulate. But what I'm suggesting in this talk is rather than getting rid of polls, what we could do instead is to replace our voting rules with non-manipulable voting rules. In that case, if I prefer candidate A to candidate B, even if I don't think A has much of a chance of winning, I'm still willing to rank A first. And therefore, the polls are not going to have such a big influence on the way I vote, maybe essentially no influence. So that's the reform agenda that comes out of a talk like this, not doing away with polls, but trying to move to non-manipulable voting rules.
Other questions?
No, if you could wait for the microphone.
Yes, I would like to ask you something about the relationship or the extension of this result to issue about non-monopolability due to failure of independence of a relevant alternative. I mean, you talk about misrepresentation of preferences, but of course we have, you just mentioned the problem of agenda setting. I can manipulate a result of the election, letting or dropping out candidates, which is also somehow related to the previous question. Yeah. If you could elaborate theoretically on that.
That's right. So another way that elections can in effect be manipulated is by the candidates themselves, as you're suggesting. Take the 2000 U.S. presidential election. Ralph Nader turned out to be a very important figure in that election. There's a sense in which he was manipulating the election. He knew he was never going to be elected, and in fact he wasn't elected. And he got about 2% of the national vote. But by running, he tried to make Democrats, Gore supporters, worried. Most people who were inclined to vote for Nader, as I said, would have voted for Gore had Nader not been on the ballots. Nader was acting strategically by running. He was trying to get the Democrats worried about his particular issues, trying to get them to take his issues more seriously. What, of course, he ended up doing is electing someone of the opposite extreme. He ended up getting George Bush elected. This, I think, is a strong reason for preferring voting rules which satisfy independence. Plurality rule violates it in a big way. We saw this not just in the 2000 election, it's happened many times in American politics. It's happened many times in French politics. In Italy, you use proportional rule, which is manipulable in another way. I won't get into that today. Most of the voting rules that are used in practice are manipulable both by voters and by candidates. But the interesting thing, at least from a theorist's point of view, is that there exist good alternatives to these manipulable rules, which could be used instead, and I hope that over time they will be. There has been a move, for example, toward using majority rule, or at least something like majority rule, not at the country level, but there are some cities which are beginning to use something like this. So I'm hoping that once people see how well majority rule works, it will be used more widely.
Thank you. I have just time to take, I'm sorry, the last question, if any. No more questions? Okay, we have a coffee break now. So if this door is open, you can join the other room, okay? Let's go. Thank you very much.